Cheers. Thanks for coming along. I know there's some really good talks on at the same time as me, so I appreciate you being here. So this talk for Optimists Our UI is pretty pessimistic. This isn't a tech talk. This is more of a UI user experience talk. So we're not going to go like really deep into anything technical. The main idea of this is to sort of plant some seeds and get you thinking about some things for when you come into for when you work with your apps and sort of taking these approaches into account. So to begin with, optimism, just to clear up what these fancy words mean. So optimism is a positive approach to events. So entering some concept with the idea that things are going to be A-OK and we're going to leave that situation with a positive effect. So for example, before this talk, I could come in here and be like, hey, I'm really pumped for this. I think this is going to go well and people are going to enjoy it. So that's an optimistic outlook. And on the other end of the spectrum, I've got my clicker, so bear with me. We have pessimism. And pessimism is the complete opposite of optimism. So pessimism is, as it states, so emphasizing or thinking of the bad part of a situation rather than the good part. So we're entering a concept or event with the idea already set in our mind that things aren't going to go as planned. So before this talk, I could be like, I'm really worried about this, I'm not sure how it's going to go, and people aren't going to enjoy it. So before I've even entered that concept, I've already got a negative mindset in place. But how does this match up with the UI? So the company I work for, Buffer, if you don't know Buffer, we have an app that allows you to buffer things like tweets and Facebook posts into a queue, and they send them out automatically. And this is a part of our app called the Composer, where you compose these updates. And this is what I've tagged as a pessimistic UI, because the users, they compose their updates and they hit buffer, and then they're shown this lovely view component which is blocking them from doing anything, which we know is a progress dialog. And this is pessimistic because we're not quite sure what's going to happen with this request that we're taking place. We're making an API request, and because we're not quite sure what the outcome is going to be, we're blocking the UI until we know what the outcome is. So this could succeed and we can close the activity, or it could fail. And we recently changed this to have more of an optimistic approach. So you enter your text into the Composer, and you hit buffer, and then the activity closes, and you can continue using your app. And already, if maybe you're on a slow network, or for whatever reason, you're already free to do other things, and you can multitask. You can carry on doing other things around the app. Maybe you want to edit some updates, or delete some stuff, or manage my social feed. And that optimistic approach gives the user much more freedom to carry on doing what your app is made to do. But why do we find this in apps? So if you open up an app on your phone now, and I know a lot of apps on my phone, this is a common problem of blocking UI. But why? Well, unfortunately, it's a predictable behavior. Users expect that. A lot of apps I use, I expect there to be a progress dialog pop up when I go to save something or send something or make a request. I expect that to happen, which isn't a good thing. It gives us an error-prone implementation. If something does go wrong, the user's in the same context where they were originally carrying out that task. So you don't have to worry about showing some error message or some dialogue in some completely different part of the app, because the user's in the same place they were when they made the request. And finally, the most important part is that it's easier for us developers to do. It takes 30 seconds to spin up a dialogue and show it to the user while that request is taking place. So, if it makes it easier for us, why aren't we going to do it? But there's some issues that come with this. So, as we know, users have to wait. So that progress dialog is valuable time that your users having to wait before they can continue using your app. And if you're on a slow network connection, that could be, it could be 30 seconds, and the amount of other things you can do in that time adds up if you add it up over days and weeks and months, etc. And finally, it makes the application feel slow. Some users won't pay attention to their network connectivity or is their networks dropping, because your application is in the foreground and that's what they're using. And if your application comes across as being slow and they're in the middle of using it, then that's what's going to get the blame. And then that leads on to recommendation, like, are you going to recommend that app to your friends if it's bad? Are you going to download other apps from that company if you've already got a bad impression from this one app? And so on. So, but why does this happen? Oh, there you go. This is what happens when I try and be fancy with animations. Why does this happen? And why do we still have these implementations in our apps? So to begin with, I tried finding some interesting facts for this. And I came across this white paper written by someone called Robert Miller. And it was labeled the response time between man and computer interactions, but we'll call it between human and computer interactions. So it's written over 50 years ago, and it was originally written in the context of typewriters. So when you hit a typewriter key, the amount of time you expect to see some state change on that paper is 100 milliseconds. So that's the point of your finger depressing from the key and then seeing that print on the page. So you're expecting to see that response in 100 milliseconds. I mean, that's pretty quick. That's 0.1 to 0.2 seconds in time. And the scary thing is that I tried to put this into a realistic value. And most of us blink, the average time is 15 times per minute. And if we divide that into a minute and stuff, we get between 100 and 150 milliseconds. So that means that by the time you blink and you're using an app, like, you should see some form of state change on the screen. And you could argue that, hey, the progress dialog is state change, something's changed, but it's not the state that the user is expecting within that app to make a change. The second point is, there you go, is network connectivity. Like, we're, as developers, like when we're in our home or our office, we're quite common that we're connected to like an extremely good Wi-Fi network. At home, like, I never have a problem with my Wi-Fi. So when we're making things and we hit, say if I hit the buffer button, that happens instantly, and I never even really saw that progress dialog because it happens so quickly. But this isn't the case all the time. Like, sometimes I'll walk down the road, or if I'm traveling, then my network connection isn't as great when I'm on my mobile network. And this isn't just a one-off for some people. There's a lot of countries where poor connections is such a common thing. And people in these countries always have poor connections. And that's where we come on to this, is these, like, we see a lot of talk about other countries and the poor network connections when we come to offline design. And so this blue one here is where is it? The GSM networks, which is like 2.5G. I can't even remember the last time I had a GSM/Edge connection on my phone. But you can see here, like Middle East, Asia Pacific, and Latin America, like, so many people in these places have poor connectivity and these slow networks. And some apps aren't in a position to be like, hey, yeah, we're going to completely support offline design. That's where optimism can help improve the situations for all users and users on these poor connections. And the last point is the failure to think. I used to work for an agency, and I worked with some really good designers, and they're really cool to work with, and we were a great team. But thinking back, this wasn't an app we designed, this is just something I grabbed off the internet, but thinking back to it, there was always, I never remember designing or discussing what would happen when content was loading, or what would happen when the user presses a button. And that made me think, like, are people thinking about this? Like, is it just me? Or do people think about what happens in these states, or do we just default to spinning up dialogues or making the user wait because that seems like the norm to do? And then some people I've talked about this with said, like, isn't this cheating? Are you lying to the user? Like, and no, if the user's aware of what you're doing, if you're displaying that content is maybe syncing or something's going on in the background, if the user is aware of that, then it's fine to do, and you just need to handle the states correctly. So moving on from pessimistic, I just wanted to look at a quick example in our app, in the Composer, where we changed this. And like I said, this isn't going to be a technical demonstration, but just something that we explored to do. So these are called finishing activities. I couldn't think of a technical term for this, but situations where you carry out a task, maybe you hit save or you change something, and that activity closes once that request is complete. So it's quite commonplace in apps where this happens. So in our case was the Composer. So when the users compose an update, we close the screen. So you can see here, We've typed our text, we perform some actions such as hitting the buffer button, and we show a progress dialog. Then we wait for the completion, and when that's finished, we handle the result. And if that's successful, we previously close the activity. Otherwise, we handle the error. And what we want to do here to remove this pessimism from this flow is get rid of that progress dialog. That's a step too far. Get rid of that progress dialog and remove the waiting from that flow. So we perform an action, and then we need to move on to the next step, which is closing the activity. So as soon as we perform that action, we want to close that activity and handle the response once that screen's out of the way and the user is free to do what they want. And the first step here is obviously the easy part, is removing the progress dialog, like just deleting that from your code and getting rid of that. Common component, in some places they are needed. So things like signing into an app, like you need a network connection there, so you can't really get away from that. And things like maybe e-commerce requests, you could argue that they're needed. But there's a lot of places where they're not needed. And the first reason for this is SDK 26, which is Android O. So progress dialogs are now deprecated. Obviously, that doesn't stop you using them, but it's a good reason not to use them. They recommend here showing like inline progress bars in place of this. But you can at least remember this screen and what I've said if you try to use it. And even if you do, you'll be shown this nice strike through when you try and use the class in your code. And the second part is shifting things to the background. So if you have an activity open that is performing some form of request, you can shift this task to the background most of the time. And there's many ways that you can do this in Android. And the first thing that we experimented with was shifting things to the background service. So when the user hits buffer, we kick off a service and we finish the activity. That service carries out your asynchronous work, and then you refresh the content. Maybe you change the state locally first, or maybe you wait until that request is complete to refresh the content. But either way, the request is taking place in the background, and the user's free to carry on using your app as you intended. So for this, we just use an intent service, just a standard service class from the Android SDK. Allows you to do stuff in the background off the main thread. And this worked perfectly because we're using this flag here on return. So if the service failed or it was killed by the system, we could fire it back up, and it worked fine. We didn't have any issues. Then came Android O. So if anyone here has looked much into Android O, there's been a bunch of changes that have come with background services. So now we're not free, our application isn't free any longer to run in the background. So all services are affected. So we can't so if we start a service when our application's in the foreground, and our application moves to the background, then that service will be killed. But if our service is running whilst the application in the foreground and that request is taking place, then it's fine. Foreground services, such as the things you see when you're navigating in Google Maps or Spotify, they work fine. And also the same for bound services, which are things used in inter-process communication. So you could say, hey, fine, I could still use the intent service, like my app's in the foreground. But the thing is, if the user moves away from your app, now in Android O, there's a small grace period where your service will still run, but then it will be killed. I don't know the exact time, but I think I've read it's between 60 and 90 seconds, which could be long enough for some places, but I don't think you should rely on that, because you don't know when the service is going to shut down. And that's where we come to the job scheduler. So if you're not familiar with the job scheduler API, we can use a job scheduler to schedule tasks against the system, and this is the recommended API to use in place of background services. So we can schedule jobs based on network connectivity or priority, or to be run at several times. And the great thing about this is now that when the user hits buffer, we don't have this in place yet, but because we're still using the service. But when we use a job scheduler, the great thing about this is when we hit buffer, we can schedule the job to the system, and the system will take care of it for us. And this has a lot of advantages to using a job scheduler, because the system can be intelligent about when these jobs are executed. So for example, say if we kick off multiple requests or schedule multiple jobs, then these can be batched to be run at the same time, which can be more efficient, and it can save our device like battery power and stuff. Secondly, we might not need to post the task instantly. For example, say if I'm buffering a tweet for 2 weeks' time, it doesn't matter if it goes out now or in the next 5 minutes. The system can be intelligent about when that goes out. We can wait on specific conditions to be satisfied. So say if I'm sending out, want to send a request that involves a massive image, I can wait until in place. And we can repeat tasks. So let's say we're making requests repeatedly to So one of the things that the next step in after we shifted to a service was manipulating local data. Because fair enough, so that screen's been closed after we've kicked off the service. But if the user can't see the change in the UI, that feels like only half the way there. So what we did was, because we put a database in place to cache all our content recently. And what you can do is, which is a similar approach to designing for offline, is writing your content locally first so that this is visible to the user. So when that service is kicked off, we can write the data locally and update our adapter to display the content, and then still kick off the service, and then if it errors, we can handle it from there. And we have a lot of cool libraries and APIs to make use of this. So for example, if we're using RxJava, maybe we start a service or schedule a job, and when that kicks off, we immediately write our data to our database. And maybe we're subscribing that to be reactive. Some error that maybe deletes this from our database when this fails, or so on. We can handle it how we like. And like I said, if we're observing for these changes in our database, we have some core APIs to do so, such as and like I said, if you are dealing with stuff optimistically or offline, it's important to reflect the state. The user should always know what's going on. If the data is currently being refreshed with the server, say if they're not seeing, say the data they've changed locally isn't synced with the server yet, the user needs to know that. And there are a bunch of apps that do this well. For example, Trello. If your phone's offline and you move a Trello card, you're shown a sync icon so you're aware that this isn't updated with the server yet. And we have other apps such as Facebook and Instagram. When you hit like or heart when you're offline, they both show you a little message that state is still reflected that that's happened. So there's some states where we need to handle things such as errors if things don't go as planned. So for example, when we kick off that service, if that fails, there's multiple ways we can do this. The user might have left the app already. So maybe we go back into the app, and it's clear to the user on this card that this update has failed and hasn't gone out, and that they need to retry that. You can do intelligent stuff with job schedulers and so on to retry things. But in our case here, we simply show a failed message, and then care of is, you can show error dialogues if things go wrong, but that kind of goes against the whole blocking UI that we're going for. So I believe that error dialogue should only be used as a last resort, if there's no other way for you to show an error message within the context that the user is in. I find snack bars to be a great way of us showing errors in our app. So on the bottom here, we have these 4 tabs. And all of these tabs, these bottom navigation bar items and these tabs, they're all within a single activity. So the user can move between these. And if the user's carrying out actions on these cards, like moving them around or deleting them, then the snack bar can always be visible within that single activity, no matter where they move between those screens. We can also make use of notifications to let the user know that something has gone wrong or something is in process. As you can see, there's an icon in the top left there. The user know that the buffer app is currently doing something. But if something fails, then it could be something that's time sensitive, and the user needs to be aware that that hasn't gone as planned. And if you're familiar with the notification API, you can use things such as heads-up notifications, so the user is aware that something has gone wrong. For in the case of us, the user might have buffered a tweet to go out at a certain time. And if that doesn't go out, then their client's going to be unhappy and so on. So we use a heads-up notification to let them know that the post has failed. Obviously, this does throw them off the context that they're in at that time, but if it's time sensitive, then they need to know that. And also, as of Android O, we have notification badges. So in Android O, we have to implement notification channels and split out all the different types of notifications into sort of groups channels. So we can do stuff with error notifications, and we have a group for that, so that we can have different priorities for those notifications, so that the user is always seeing them in the application. And just as a last note, I kind of feel like optimistic design and offline go hand in hand. So for us, obviously the dream would be to have like full offline support on our app, but because we're dealing with a lot of legacy code and the code base isn't that tidy at the moment, it's hard for us to sort of do a complete overhaul and support offline fully. And I find like optimistic design is a step in the right direction, because we never had a database before, and we needed to put a database in place to support offline, to support optimistic design, so we could cache things and react on that. And it also gives us the benefits of a few other things. So as much as I love this cute character we have when there's an error, it was quite annoying seeing this. You know, it kind of looks a bit crappy. So now having a caching method in place to support optimistic allows you to make use of that data in places in your app. And whilst you're not fully supporting offline, you can still reap some of the benefits of having that data available when the device doesn't have a connection. And the same goes for progress bars, because even if the connection is slow, we already have data available to display to the user, so we have no need to show that progress bar. Again, we can show the cache data and show in some other place on that screen somewhere, or in status bar, that data is being synced and the fresh data is being retrieved. Cool. So that's it from me. Like I said, it wasn't extremely technical, but I'm hoping some ideas have been planted, like for future when you go away and you work in your applications to implement some optimistic approaches. And hopefully you'll see the benefits from it in the speed of your application. And like I said, we're not breaking any groundbreaking territories here.